Chapter 15, the Jfet Amplifier and Buffer. We will design the Jfet Amplifier and Buffer. They are quite similar to the design of the bipolar transistor, but the only difference is that the Jfet application is very high input impedance. So transconduction characteristic leads to very change in the gains and linearity. So in this circuit we make an amplifier for Jfet. This is the circuit we're gonna make in simulation. Now the parameters we chapter 10, 15. FET amplifier. First we make an FET Jfet amplifier, make a directory folder. Now press OK. The difference between the Jfet and the VFET is that only we can vary the gain by varying the transconductance, and we can also change the linearity. So we're gonna study the Jfet amplifier here. Add the libraries. J213, Jfet. Now add the ground for the biasing circuit, 2 for the input and 1 for the output, 2 for the biasing circuit, the registers, rotate the register. We need 4 resistors. We need for biasing circuit for the drain, so make a VD circuit with 3 VD resistor. Use the resistor R4, and we need 1 circuit for the input, so we use the source input and we will use the coupling capacitor. 1 coupling capacitor for output, this for coupling up for input. That's the resistor for the base connected. Rotate this resistor. We want one resistor for the source. This one we use connected to the source. 1 parallel capacitance for the source for remove the AC components. We need a VDD. That's our source. We need the AC source. In the editing property, we want to implement the off time AC. We want AC of 1.5 volt. We have amplitude of 1.5 volt and a frequency of 1K. We have V of 0 connected to the ground and one side connected to the coupling input capacitance. CC1 is the input coupling capacitor. We need 0.1 microfarad. That's a net alias for V in. We need for the making graph. This one is the base resistance. That's the source resistance. That's the load resistance of 2R, 2K. The output net alias. That's RD. Drain resistance of 2K. That's VDD, 20 volt DC. Make it 20 volt. DC supply is will bias the drain. Make forward biasing the drain. You can control the transconductance. Name the simulation as Jfet amplifier. Now, we also need to analyze the harmonic distortion. So first of all, runtime 10 millisecond to 10 microsecond step. Now perform a Fourier analysis. We give the 9 number Fourier harmonics, 10K center frequency and output variables to be like V output 1. So this will generate we get the harmonic distortion over here and so this much percent, 57%. Now we, for the effect on game, open the file, make the changes in the starting frequency and end in the period time, run the simulation. Now that's the V output by input on dB square. That's the gain. We got it. It is below 6. Now increase the value of change the value of RS to 200. Run the simulation. The gain will decrease. V output by it's now decrease. See, this was 6. It's above 4 and below 6. Now change RS 300. Run the simulation again. V output by V input, it is below 5. Now again make RS 350. V output by V input, the gain is decreasing. Change it by 400. Again run the simulation. V output by V input is below 5, getting more below 5. The new page, Jfet Buffer. We open Jfet Buffer, draw the circuit, add the libraries all, That's Jfet. Keep all the component R's and C's. Voltage divider make a C1, CC1, 0.1 Faraday. Rotate the resistors so that make a voltage divider near the base. That's RS connecting. Connect the R3s. That's VDD. Connect RB1. Now rename all the parameters and give some values. Voltage amplitude 6 volts, 1k frequency, 6 volt, 1k frequency, and C1, C3, CC1, 0.1 microfarad, RB1, 2 mega ohm, RB2, 2 mega ohm, 20 volt DC supply VDD, RS 2k, 1.5k, 1.8k, 10 microfarad CC2 output coupling capacitance, net alias V1 input 2 and V output 2 for input and outputs. Make a 10 millisecond. Run the simulation by making Jfet Buffer new. Change the parameters runtime for only for 10 millisecond. Give the harmonics. Center frequency 1k, 9 harmonics. V output 2 output variable. So we're gonna run the simulation. This is the harmonic distortion for the buffer 2.755980E minus 2%. That's the harmonic distortion for the buffer.